Now we want to look at our second scenario. Given a network address and a set of customer requirements or a set of needs, come up with a subnet mask. We'll also use the 2 to the nth minus 2 rule for this one. In this example, scenario number 2, given a network address and a set of customer needs, here are the customer needs. The customer has given us a 172.16 network, and they say, well, we need to break this network up into, we've got 6 departments, and each department we want to be able to have 2,000 hosts per department, or 2,000 users in each one of those 6 departments, or 6 sites. You could view it as 6 different sites or regions. We'll take these customer requirements or this set of needs and break this network address up so that we can meet these customer requirements. Remember, what we'll use is the 2 to the nth minus 2 rule to determine how to come up with enough bits in the subnet mask for the 6 departments and how many bits to use for the hosts. So let's take a look at that. Remember, the first thing that we always want to write down is the mask. By default, we have a mask that's given here by the customer since we have a Class B address. The Class B default mask is 255.255.0.0. So this is the default mask that's given. The address that we're given, 172.16.0.0, we want to write that down next. Okay, remember we're writing down the decimal in the first 2 octets because of the defaults, and then we're breaking out the rest. I also like to call these the interesting octets because this is where things get a little interesting. This is where we'll begin changing the bits in order to accommodate our needs. So, starting with the default mask, we now have 2 sections, a network section and of course the default section, the host section. We cannot change any of the bits to the left of this imaginary line right here. To the left here, we can't change any of the network bits. So can't touch those. But we can manipulate or change host bits in the mask here. And what we'll do to accommodate this 6 departments or 6 subnets that we need is begin borrowing bits in order to arrive at the number of departments or the number of subnets that we'll need. So, using the 2 to the nth minus 2 rule, let's borrow 1 bit here, thus creating a new section, this subnet section, and this subnet section has 1 bit in it now. So if we use that, that would be 2 to the first minus 2. 2 to the first is 2 minus 2 equals 0. So that's not enough bits to borrowing the 1 bit. So we have to borrow another bit. If we borrow that second bit, that brings us to 2 to the second minus 2. That's 4 minus 2. We have 2 subnets with borrowing that much. So that's still not accommodating our needs. So we have to borrow another bit. We borrow this 3rd bit, and we have 2 to the 3rd now. 2 to the 3rd minus 2. 2 to the 3rd is 8 minus 2, brings us to 6. That accommodates our needs here. So, that would be an adequate mask up to this point from the standpoint of covering the number of departments that we need. So let's see if that leaves over enough of the bits for hosts in order to accommodate our needs there. So we'll draw this red line here just to separate or differentiate between the host section here and the subnet section that we've created. So with this new mask, that leaves us with 5 plus 3, that's 13 bits that we have there. So 2 to the 13th minus 2. Now what I like to do is I like to use landmarks to remember these exponents. I know a lot of people are looking at this and you're thinking, well, I can't remember all those exponents. What I like to use, just by way of some shortcuts, I'd like to memorize a couple of particular landmarks. 2 to the 5th and 2 to the 10th. 2 to the 5th is 32. 2 to the 10th is 1024. If you memorize these landmarks, you can easily work your way from those landmarks to the next exponent up or down from wherever you are. Say, for instance, it's 2 to the 6th that you're trying to remember. Well, 2 to the 5th, you know, is 32, so you double that and you get 2 to the 6th, which is 64. So if 2 to the 10th is 1024, if you want 2 to the 11th, you double that and you get 2048. You double that, you get 4096 for 2 to the 12th. You double that, you get 8192 for 2 to the 13th. And that's sort of the way I do the exponents and figure out a short way to remember the exponents and quickly get to those. That's particularly helpful when you're taking a test. So 2 to the 13th, we know is 8192 minus 2, 8190. That covers our needs. So we can use this subnet mask to cover our needs. So the question was, given a network address and a set of customer requirements here, provide a subnet mask that meets those requirements. So our subnet mask that we've come up with is based on the number of bits that we've borrowed here to accommodate the customer needs. Now, some people will ask the question, why not start over here and determine how many host bits you need first and then go to the subnets? I prefer starting with the mask and going in that direction just as the mask extends. But this is really going to boil down to what your customer needs, whether they need more departments in the future or whether they're going to need extra expansion in the future as far as hosts are concerned. So the subnet mask that we've come up with here is 255.255, and now we've got to figure out what this number is right here. That number is 128 plus 64, that's 192, plus 32, which is 224. So the subnet mask that we come up with here is 255.255.224.0. That's the subnet mask that answers that scenario.